Welcome to the deep dive. Today, we're looking at a classic installation problem, really, the hard limit of copper wire.
Right. How far can you actually push a signal?
Exactly. And to figure that out, we're jumping into the specs for the Kramer CP-AOCDP UF-33 cable.
Hmm.
We really want to understand what bleeding-edge DisplayPort tech looks like when you need it to cover a serious distance.
And that's the key. This isn't just about speed, it's about speed over distance.
Our whole mission today is centered on this one, frankly, staggering claim, delivering full 8K resolution over 33 feet.
Yeah.
I mean, we all know that trying to run high-res data past, 15, maybe 20 feet, it's always been a nightmare of signal boosters and extra power supplies.
It has.
Yeah.
And you have to understand, that's why this product exists. This is not a passive copper cable just, trying its best.
Okay, so what is it?
It's an active optical cable, or AOC. It's built specifically to use the absolute maximum bandwidth of DisplayPort 1.4.
The kind of bandwidth that needs light, not just electricity.
Precisely.
So let's look at those raw numbers then. The spec sheet says 32.4 gigabits per second, maximum data rate.
He does.
So what happens historically when an installer tries to push numbers like that over 30 feet of copper?
You get signal drop, you get massive error correction, and, eventually you get a black screen.
Right.
To hit that 32.4 GBPs, you need the DisplayPort 1.4 HBR3 link rate. That's high bitrate 3.
Okay, HBR3.
It means you're pushing 8.1 gigabits per second across each of the 4 data lanes inside the cable. That's the foundation for this whole thing.
And visually, for you, that translates directly into a clean 8K resolution at 60 hertz. That's 7,680 by 420 pixels.
And it does all that while still supporting things like HDCP 2.2 for content protection and ED for that stable handshake between devices.
But, in professional AV, audio is just as critical. Latency, quality, what's the story there?
It doesn't skimp. The specs show support for up to 8 channels of 16 or 24-bit linear PCM audio.
Oh, okay.
Yeah, and with sampling rates from 32 all the way up to 192 kilohertz. So you are getting full high-fidelity audio right alongside that massive video stream.
So the numbers are huge, which brings us to the really crucial question. We know copper fails at this distance, so how does this cable physically maintain that signal across 33 feet?
This is the really fascinating part. It's a hybrid construction.
Hybrid.
Yeah, the super high-speed data, that's actually handled by 4 multi-mode optical fibers. Glass.
Okay, so fiber does the heavy lifting. Then why keep copper at all? Why is it a hybrid?
Because that copper carries the essential power and control signals. It's how the tiny active electronics inside the connectors can talk to the display and the source.
Got it. And that power, where does it come from?
That's the beautiful part for installers. It pulls all the power it needs. And it's tiny, less than half a watt per end right, from the DisplayPort connector itself.
So no external power bricks to hide.
None. You avoid all that clutter and hassle completely.
That is a massive win, especially when you hear about its physical size. The outer diameter is only 4.8 millimeters.
Which is incredibly thin.
Anyone who's tried to pull thick, stiff copper cable through a tight conduit knows how important that is.
And that thin profile doesn't mean they sacrifice safety. This is key for any commercial or public space install.
You're talking about fire ratings.
Exactly. It has a Plenum rating. That means if there's a fire, it's not going to release toxic smoke into the air handling spaces. It's also LSHF, compliant, low smoke, halogen-free.
So let's just synthesize this for you. What this product really does is it solves that fundamental trade-off, right? The one between speed and distance.
You get the 8K bandwidth, but you get it over a useful length.
All in a package that's thin, safe, and doesn't need its own power outlet.
But here's the final provocative little detail, a final thought.
Oh.
Even when you conquer all the electrical limitations with fiber optics, you still can't defy basic physics.
What's the catch?
The specs require a minimum cable bending radius of 48 millimeters. You're trading one problem for another. You can't just kink this cable around a sharp corner. If you bend those optical fibers too sharply, you lose the light. You lose the signal.
That 48 millimeter constraint is a great reminder, isn't it?
Yeah.
This cable solves the data problem, but it creates a new physical installation problem to think about.
It does.
So what's next? What new innovations, maybe flexible glass or different pathways for light, will solve that final physical hurdle, that feeling of you just can't bend light?
That's the challenge for the next generation.